So it's my great pleasure to welcome everybody to Mohammed Ahmad Licentiate Seminar. I'm Andre Sabelfeld, advisor of Mohammed, and I'll be chairing this seminar. So it's great that today we have Professor Dejan Stefan, who's playing the role of discussion leader and helping us assess the licentiate thesis of Mohammed. And other players today is Supervisor Daniel Hedin, who is also here in the call, and David Sands is the examiner at Chalmers, who will decide whether or not Mohammed passes the requirements for licentiate, including this seminar. So many of you know already the format of this seminar. So essentially, we start by Mohammed presenting the thesis. It takes 45 minutes. After that, we take a very short break and give a chance to Dayan to ask questions about the thesis. Have a Q&A session between Dayan and Mohammed. After that, anybody in the audience can ask questions as well. So that's the rules for today's session. Okay, with that, I'm happy if Mohammed takes over and starts presenting the thesis. Please go ahead.
Right. So, hi everyone. I'm Mohammed, and thanks for coming to my Licentiate Seminar, both in person and virtually. So today I'm going to talk about how to secure software in the presence of third-party modules. So modular programming actually mainly focuses on logically separating the functionality of a program to independent yet reusable code modules, which are mostly written by third parties. So it means that it accelerates the software process, but at the same time, it aggravates security concerns, such as stealing confidential data, tampering with sensitive data, or executing malicious code. So here in this thesis, we focus on two main security policies: access control and information flow control. Access control basically specifies the list of permitted access requests of an authenticated user, and information flow control actually tracks the information propagation through executions of a program. So, and these two are complementary because access control is not sufficient after access being granted, so there is no control on the sensitive data anymore. So the included papers here in this thesis are these three, which, as you can see, we have contribution both on the theoretical and practical aspects of language-based security. The first two papers are related to access control of, or I would say, securing trigger action platforms. And the third one is related to IFC, which I'll talk about this later. So let's get to the first two. What is trigger action platform? Trigger action platforms are platforms that connect otherwise unconnected services and devices in a uniform way. So actually, we can say that there are some apps in this platform. We have like trigger services and action services, and once a trigger, upon a trigger, the app performs an action. So this is the idea of these platforms. And we can say that there are different devices such as smartphones, cars, like smart home, like different services such as Google Drive, Gmail, and social networks, and etc. So here are some examples of the actual tabs that we were interested in and we studied. So the first one is if, the acronym of if this, then that. And here is one example of an if applet or app. So as you can see here, we have like get an email when your camera senses motion. So we have like camera motion as a trigger and getting an email as an action. And as you can see, that's just it when you actually communicate with the interface of if. But on the backbone of its app, you can have like some scripts in the middle of trigger service and action service, which is called filter code. Zapier is another one, and an example that I picked here is save new Instagram photos to Dropbox. Again, trigger action, and we have some code steps here that can modify the modify the code between these two. And the third one is node-RED, which is a bit different from the architecture of the former ones, which you have like different nodes offering different functionalities, and you can wire them together and have like more complex applications. So trigger action platforms, as I just described here, essentially are persons in the middle. It means that they act on behalf of the user. So this is a bit dangerous because we should actually trust them in some sense. And also, they employ end-user programming. What does it mean? It means that end users in these platforms can create and publish apps on the web, on the app stores. So it means that most of the apps that we're using in this platform are written by third parties, such as Thunder, Canary, and everyone. So why should I trust them? As we just saw, so we have popular JavaScript-driven tabs, if and Zapier, which are commercial, and node-RED, which is an alternative open source that you can actually deploy on your own hardware. Just to make sure that they're popular, there is a statistics that says 18 million if user running 1 billion apps per month and connecting more than 600 users. And that was like for a year ago, I guess. So here is the architecture of tabs with the third-party code, the code in between trigger and action services. So in Zapier and node-RED, we have the architecture of single tenant, which means that all three are built on Node.js environment, but Zapier and node-RED picked like an isolation per Node.js instance, which means that each of the user actually has their own Node.js instance on this level. So we can have like, we could make sure that the different user cannot actually manipulate with each other. So the third model in this paper is malicious app maker. So that we're going to see that how actually it can actually make the platform insecure. But if picks another strategy and is like multi-user can share one single Node.js instance, which means that these two should be isolated at the software level. Again, the third model is malicious app maker. So if and Zapier actually provide some sense of sandboxing. Both of them are run inside AWS Lambda, and Node.js instances run on AWS Lambda. And we have like built-in sandboxes at the process level for both of them. For example, if in the documentation says that filter code is run in an isolated environment with a short timeout. And here is like the skeleton of what you will see at the backbone of if, which you have like this string of filter code and it evals the script. So to provide this isolation, if offers some security checks of the script code, both static and dynamic. So we have like static type checking for the TypeScript, and dynamically it's allowing eval, module, sensitive APIs, and IOs. So it means that if is very restrictive in this sense. So the question here is that the first question that we're going to answer here is that are the tabs actually secure in the presence of third-party codes or not? So we actually found sandbox breakout for if, and in this scenario, user are just benign and innocent, installs benign apps from the App Store, but we are like malicious app maker, a legitimate user in this system, and we actually can break out the software level isolation of if with the combination of prototype poisoning and evading the security checks that I just mentioned before. So the idea here would be the malicious user can actually compromise the confidentiality of trigger data and the integrity of action data of another user, but in the same Node.js instance. So the idea here is that we're attacking the other users. For Zapier, we have like this architecture that there is just one single user per Node.js instance, and now malicious app maker should somehow trick the user to install the malicious app, which is somehow common because you can give some code from other forums or like somewhere. In case of Zapier, you cannot actually publish your own code as like a valid Zap, but in if and Node-RED, you can actually do that. So the user actually has been tricked and installed the malicious app, and now the same scenario happened because the trigger and action of the same app are compromised, and the other apps, the other apps that the user have in the same system, the same environment would be compromised. So this is also valid for if, because it also has like single user per instance. Here's node architecture. As I told you, it's a bit different from these two. And now you have to like complex like nodes connecting to each other, and you can see that there are different tabs. Each of the tabs named flows or Node-RED apps, and they're connected, and they're consisting of the connection of different Node.js nodes. So these are Node.js nodes and connected via the wiring, and they're running at the same time. And as you recall, Node-RED is open source, and you can actually run it at your own hardware. So to model the Node-RED architecture, we can say that Node-RED is built on Node.js. We have different flows running at the same time. There are some explicit message passing within nodes via the wiring that you saw. And there's also some context, shared context between nodes within a flow or between two flows. So we call them flow context and global context. So in Node-RED, we should actually say that what's the security policy here. As we saw earlier, so the user can see the graphical view of each of the apps. So we can say that this is, we can actually interpret this graphical interface as the security policy that user intended, because that's what they can see. So we can say that information may only flow with regard to the wiring. So it means that now the security actually, the security in Node-RED means the security of each node or the shared context that they can communicate. They can communicate some other messages. So each node should be secure both in terms of integrity and confidentiality, and of course availability. So it means that if there is some malicious node in this system, the whole app or the whole system would be compromised. So what are the vulnerabilities that we found in Node-RED? So malicious node may have like access to Node-RED object and Node.js module. First one is that because of there is like lack of sandboxing or isolation in the Node-RED nodes, so like powerful modules like child process can be required, and they can run any arbitrary code on your system. So you have Node-RED, there is a malicious node, and your whole system is controlled by the attacker. Or the red object, which is like the main object in the Node-RED system, can share some can be port type poisoned and share some other share some malicious information within the different flows. So the solution would be that we need access control at the level of modules and the shared object level in Node-RED. Again, the malicious node can actually manipulate with the functionality of code in the sense that, for example, in the email node, which you have like the receiver of the node is represented by the property of 2 in the message. Message is the wires that you had, the object in the wiring. So the malicious email node would be simple policy a simple program actually modification. It adds its own attacker address at the end. So it means that once you actually use the email node, a copy of your message will be sent to the attacker, which means that we need access control at the level of APIs and also their values. Actually, we did an empirical study which shows that more than 70% of flows, node-RED flows, may violate privacy or integrity. In terms of the vulnerabilities in the shared context here, we can have like exploit on inter-node communication. So here's an example, a real-world example of flow named water utility targeting SCADA systems. As you can see, here's like a tank level, and based on the tank level, it says that water should stop or start. But as you can see, it's shared with the global context. It means that any node in any of the flows in Node-RED can actually read or write to this shared context, which means that you can actually make the pump never stops or never start. So it would be like physical damage. And interestingly, you can also share some resources, such as like any objects or any objects that you like. For example, here, a require has been passed as a globally shared object. And at this level, we also need access control at the level of context, because now the attacker can actually put their own version of require or their own version of OpenCV, and that would be like controlling over your program. Our empirical study shows that roughly 20% of our flows make use, 20% of the flows make use of context. So it means that they're vulnerable to these type of attacks. So to wrap it up for a Node-RED, the breakouts are, again, malicious app, which means malicious flow or node, can actually compromise the other apps and the tap itself. So the other apps of the same user and the tap itself and the host system. So the question would be how we can secure JavaScript apps on these tabs. So our idea was access control by secure sandboxing, and at the level of module and context, because Zapier and Node-RED must use some of the modules, but if doesn't allow any access to modules. As we have seen, so there are some like powerful modules that can be controlled by attacker, and there are some shared objects in the context. So we need the granularity of module and context level. And also, for example, in if, it says that the filter code should never access to any of APIs other than the APIs given by trigger and action, or these two which are specific for time, the trigger time or the user time. And more interestingly, all of them should not leak any sensitive information via values, for example, private URLs or the email attack that we've seen. So we also need fine-grained access control at the level of APIs and their values. So the question would be how we can actually support these type of fine-grained policies. Here's our solution, Sandtrap. So in paper 2, we presented the modeling of Sandtrap as an essential model of Node-RED. So as we observed earlier, so there's like two types of policy examples that we had. For example, only me as user is the permitted email address that you can use for the email node. And as we've seen, the water utility flow needs some globally shared variable. So it means that just a very few of the permitted nodes should actually have access to the global variable. So we actually added we actually attached the security policies per node, these three, and these three are related to node configuration itself in the Node-RED world. So P stands for the permitted API values, V are the permitted values per APIs, and S is for shared access. It means that which of the flow or global variables can be read or written by this particular node. So here are the sense of our monitor. We can actually control API calls via here and at the level of values. So now we can actually control that send mail is a permitted API call, but this one is not a permitted value of this API. And for the shared access, we can say that only if the nodes has the pair of tank level and R or tank level and W, they can read or write to the tank level. Otherwise, these three rules will block the execution. We prove the soundness and transparency of our monitor. It means that we prove that the monitoring at the node level enforces the global security. And for the transparency, it means that if the security complies with the, if the node complies with the security policy, it cannot sense anything, the presence of monitor. And also we preserve the longest prefix of, longest secure prefix of the execution. We also implemented Sandtrap. So this is like a, Sandtrap is a novel JavaScript monitor that can enforce policies at the level of read, write, call, and construct. That's exactly what we need. So it can actually securely use of modules. Now we have like access control at the level of modules, so we can pick which of the modules are permitted or not. This is unlike the other types of monitors like isolated VM or secure ECMAScript, which actually their approach is all or nothing. So they provide you a complete isolated context with no modules and everything, or you have like a full control. Sandtrap is structural proxy-based membrane, proxy-based that uses two-sided membranes with symmetric policies. As you can see here, you can control all the interactions between host and Sandtrap via the proxies at the both domains. And it's based on Node.js VM module, which is quite similar to VM2, but VM2 is not at the level of the granularity that we would like, because it's just at the level of module and APIs based on mapping the modules. But we need more fine-grained access control, so we have to actually create something else. So now at this level, we have everything that we need at the 4 levels that we would like to have. Now, the problem would be how the policy look like, and how the policy in Sandtrap should be generated. So Sandtrap is equipped with policy generation. You can put it on the learning node, and per execution, it will generate the policy of the JavaScript code that you gave it to Sandtrap per execution. So it means that if you have a Node.js node, after a couple of executions that you have the good coverage, you will have like the policy that you need for Sandtrap. Here are some examples. For example, you can specify which modules are permitted. Otherwise, if they are listed in the manifest, it's permitted. Otherwise, we have like default deny configuration. So here are the API example. We have like call policies, and you can allow them by true or false. And you can also have set some policies for the arguments and the return values. For the values, you can actually list the values that are permitted, or you can use the parametric value sensitive feature of the policy generation, which means that you can actually set a policy parameter, for example, here target, and based on that, it dynamically checks whether the arguments of this call is equal to the value of target at that point or not. And for the context, or for the objects, we can have write and read policies, which we can say that they're permitted or not. So for the platform, for the triaging platforms, we have baseline and advanced policies. Baseline policies are the ones that for all apps per platform. So it means that, for example, in IF, we say that no module should be should be permitted to require anything in the filter code, and can be set by platform. And per specific apps, we have advanced policies, which means that the developer of the code or the end user may suggest the policy, and they can write the policy, but the platform at the end will set it. And all those like email addresses or the value sensitive policies can be set here. So that would be like baseline policies for these three. If doesn't need any modules, any APIs other than the trigger an action, or any IOs, and the moments API, which is for the time, should be read-only. Similar thing for the Zapier runtime, we need read-only protection of what Zapier actually exposed. And for the Node-RED nodes, we should just actually focus on some of the calls that might need by the RED object, the main objective of the Node-RED. We actually experimented Sandtrap. We actually instantiated Sandtrap with these three and experimented some secure and insecure applications. And as you can see, the baseline policies can protect the platforms from the attacks that I mentioned earlier. And for the value-sensitive policies, for example, in this case, take a photo from an Instagram post, we showed that it prevents the leakage of the, for example, photo URL or exfiltrating data in general. And for the water utility control scenario, we can make sure that no other nodes, rather than the permitted ones, can play with the shared context. So here are the results of our experiments that the overhead in if at the worst case would be less than 7 milliseconds, and the policy is pretty small. For Zapier, the worst case was less than 12 milliseconds and 260 lines of code for policy. And for Node-RED, the numbers would be a bit higher. The overhead is less than 100 milliseconds, and policies are much bigger because now we have like more complex nodes in Node-RED environments. So here's Sandtrap monitor, proxy-based monitor to enforce fine-grained access control policies at the 4 levels that I introduced. And we have also a formal framework for a core language that we showed the sounds and transparency of that. And here is the face of Belcher. So far, we have talked about these 2 papers, and now it's time to present briefly the third one, non-transitive policies, which talks about information flow control. So what is non-transitive non-interference? It's a non-standard notion of non-interference presented by Lu and Zhang in CSF 20 for actually for coarse-grained information flow control. It means that their goal was to specify the security labels at the level of modules, not at the level of variables, and then based on that they can actually have third-party code in their program with the specified labels. So the idea here is that unlike the classical dating styles information flow policies, the flow relation is not transitive, it's just reflexive. It means that any arbitrary relation can be here. So it means that all the flow relations must be specified explicitly, otherwise they're not permitted. So for example, here in this case, it means that Bob can only share or send is information to Charlie if it's not influenced by Alice. Unlike the style that it says that if A can flow to B, B can flow to C, it means that A also can also flow to C. In this program, you can see the explicit flow from Alice to Bob, because Alice's data will be sent to Bob here. And now Bob, the data 1 is influenced by Alice's data, which the bad method actually sends the data to Charlie. For this type of non-interference, they introduced a non-standard enforcement mechanism and type system. So here you can see that we actually label modules, and all the variables of each module will be labeled as the same. And this is like the condensed version of the code that you saw in the previous slide. There are two types of labels, specified and inferred. Specified are static, but inferred labels are actually collected by the information flow history of the program until that part of the program. So here, but the data 2 will be just B because no one else influenced that thing. So in the assignment, it checks whether the type here in the inferred labels actually can flow to, is in the list of the permitted flows to C. So they actually introduce a notion of can flow to a label, which is the set of labels that can flow to a label. So in this case, B is a part of this set, so it's okay. Similarly for the next one, but for the third one, because above the data 1, now it also aggregates the label of Alice. Now we can see that it's not permitted anymore in this assignment, and it's a bad assignment. So what we did in the third paper, we actually showed that NTNI, non-transitive non-interference, can be reduced to the classical transitive version. So it means that actually the whole literature of the transitive information flow machinery can enforce non-transitive non-interference. But how? In these two steps, we need a lightweight program transformation and less encoding. So the idea here is that instead of actually dropping the less assumption, we make a power lattice out of the non-transitive labels, and we keep using of TNI now in the transformed version of program. So here is the transformation of a program. So we have the original program. At the first step, we keep the program as is, but replace the variables with internal temporary variables. So nothing has changed. The idea is that we should actually separate source and sink variables to label them differently to actually can capture the essence of non-transitive flows. So we need the initial part that shows that this is like the source variable that has an assignment to temp variable. Now we can control and label the source variable something else. And we have the final assignment at the end that actually the sink variables would have the same level of the set of can flow to L, if you remember. So in this sense, we can actually see that the meaning of the program is preserved, semantically is preserved. Of course, modulo renaming and having the extra variables. Here's the powers of lattice. Now we're gonna actually specify the new labeling. So for the source variables, we'll have the single set of L, which means that A source, B source, and C source here. And for the sink variables, we'll label them as the set of can flow to. So that would be A sink, B sink because A can flow to B, and C sink because B can flow to C. And that's it. So here's the theorem that we show that for any program C And any non-transitive security policy, we have a semantically equivalent program SIG-prime and a transitive security policy with the labeling transition that I just described. And here is the main result of this paper. So what's next? Now we can actually leverage the enforcement mechanism that we had earlier. So it means that we have the transpiler here. It gives transitive policy and program. It changes, it translates non-transitive policy to transitive version, and it transforms the program. And now you can actually use the flow-sensitive type system on one of the candidates. So for a small calculus of the paper, we use the flow-sensitive type system of Sebastian Hunt and David Sands. And we've shown that this is more permissive than the specialized type system of the main paper. And for Java, we also use Joanna as a flow-sensitive information flow analyzer, and we did some case studies. Here's just an example of a Joanna-based analysis. You set the power lattice at first, then labeling for each variables of the component or module, and at the end, you run the classical flow sensitive of Joanna. And this is likely the script for the running example that I showed. So Joanna says that there's an illegal flow from Alice, the data source, to Charlie, the data sink, because it's visible to EC. So in the third paper, we actually showed that inspired by the set of 20 paper by Luan Zhang, we've worked on non-transitive interference, and we showed that it can be actually reduced to transitive version, and the existing information flow machinery can be reused for these type of transitive policies. We also offered another lattice encoding, and we also showed that for the programs with I/O, the transformation would be much more straightforward because it just focuses on input and output commands. For more information about the paper, you can go to this URL or you can wait for the discussion. Here are the included papers in my licentiate thesis. The first one with an excellent team of co-authors. The first one was accepted in Usenix 21, and the second one, which is about the modeling of the monitoring node grid, has been accepted to Joshua.NET's first street. And the third one, non-transitive policies with collaboration with Aslan Askarov and Andre, has been presented in your Licentiate. So thank you everyone for listening to my talk, and I'm ready to discuss about the papers.
Okay. So thank you very much, Mohammed, for this presentation. And as promised, we'll take a 5-minute break and meet at 4 p.m. Gothenburg time to do the Q&A with Diane. So break until then.
Thanks.
Welcome back. At this point, we give the word over to Dayan to start the questions with Mohammed. Please, Dayan.
All right. So I'm gonna maybe start with low-level questions, and then maybe we can get into like the higher-level bits and your vision for the world. Oh, there we go. Okay. So maybe we'll start with the kind of chronological order that you presented things. So I guess like one thing that wasn't clear to me is there sharing between modules, and kind of like how does this affect both isolation and kind of the kinds of applications that you can build and wrap. So like even like the Node-RED example, right? Like is the wire like, is there a copy happening across there, or are you sometimes sharing direct objects across these boundaries?
You mean in the wiring, right? If I get it correctly.
Sure. Yeah.
Yeah. So basically, between the wiring of the Node-RED nodes, there is a message object that shares, and actually this is what conveys from one node to another. So this is like a direct message sharing between each of the nodes.
Well, like, sorry, what I mean is like, can I convert that message to a string, and on the other side convert it from a string back to some kind of like object? Or is there like ever like an interesting kind of like more complicated object reference across the boundary?
Across the boundary of the isolation that we have, or in Node-RED, in simple Node-RED?
Both.
So in simple Node-RED, the message object is like any other objects that you can actually, for example, as you said, serialize an object through the string property and get it on the other side. So in the isolation, the message object is given as secure because it'll actually traverse the wiring, you know. Otherwise, I mean, if any messages that can pass through the nodes would be assumed as secure, because this is what actually the end user can see in the graphical user interface. So we're not concerned of the message passing between nodes with explicit links.
Presumably you are though, right? Because if I pass in some rich object, then like that thing might have a prototype, and I can use that prototype to then get at whatever. Yeah.
Mm-hmm. Yeah, but that would actually compromise the message object, the Node-RED message object, right?
Not necessarily, right? Like if I have if I can get to the global through the prototype of this object, right?
Mm-hmm.
Or like, why can't I do that?
So because the message object doesn't have access to the shared variable itself, but the red object does. So there are two main objects in the Node-RED architecture. The first one is red, R-E-D, which is actually the executor of each node. Actually, it is the trigger of each of nodes, and there is a message that passes between nodes. So we actually have policy on the red object, which has access to flow and global shared variables, but message is like a local variable at each of the nodes that sends to the another one. And as long as it actually propagates through the wiring, so we assume that the whole thing is secure, or at least is like an intended policy of the user. Or still, if maybe I'm answering another question, or if you think that I misunderstood the question, please.
Yeah, I guess I'm just curious. Like there's like even passing, let's say, a simple JSON object across a boundary, right? If I have an array, like I can use that array object to then get at the global array constructor, right?
Right. So it's still the message object inside each of the node has its own policy.
Yes.
So we have policy for message objects inside each of the nodes. So if the policy actually blocks it, so that would be all right.
Okay. Okay. That sounds. I think I am just like missing some bits of like how Node-RED works. Okay. I guess like so in the same Node-RED bit, the thing that wasn't clear to me is like, what is the isolation boundary? Are each of those nodes running in like a separate like V8 isolate or like context, or are they all in the same V8 context, but they're using like, I guess, like module type things to isolate each other?
Again, in the Node-RED without Sandtrap, there isn't any isolation between nodes, so they live in the same Node.js instance.
Okay, and in your world, in Sandtrap, they're two separate separate contexts.
Yeah, nodes are separated, isolated, and separated from each other.
Specifically in like a V8 context, or how?
Actually, Sandtrap uses the VM-based approach. So they actually have like their separate context per node. And the interaction between the host word and Sandtrap word would be governed by the traps of each, I mean, the two-sided membrane and two-sided host.
Sweet. Okay, that makes sense. Okay, so I guess the question that I have now is, when you're running things in kind of like clean V8 context like this in a fresh VM, did you run into the case where like trying to take an existing app or an existing node would break because of it running in a clean environment, right? Like if I have some class and I create objects of this class and pass them across the boundary, like, you know, the instance of would fail, right? Because presumably it's a different class because you've created an object in one context and like passed it across. So have you run into like compatibility type problems with this?
Yeah. Actually, it depends on the structure of the node. For example, one of the Node-RED nodes is like function node, which basically evaluates something. So depending on the policy of each node and the exposed API of that, so it might break the functionality of the node or not. So for example, in this scenario, if you, for example, in the function node, if you want to have like the full access of the function node, you should permit the evaluation. So in this sense, this is like maybe more than enough exposed API to manipulate with other things. It means that it depends on the functionality of each node. So as long as, for example, one of the other nodes is ncan function or something like that, which the node has access to require. So in that sense, you should actually just kill the node because it's insecure in general, or accept that this node's functionality needs these kind of security policies.
But you could imagine exposing your own require, right? And like giving it a virtual, like whatever module object it was asking for, right? You can kind of mock that kind of thing. I guess my question is like a little bit maybe broader than that. Like have you looked at like existing apps and like saw things break because of your isolation environment?
Yeah, actually throughout the developments of Sandtrap, mostly in if and Zapier, because they were like smaller code snippets, we were okay. But for the Node-RED benchmarks that we had to actually somehow like we need to modify the code of Sandtrap and develop it in a way that the functionality of the node can still work, and at the same time we can have like the policies. So, but for the benchmark that we had, which is like 10 flows, I don't recall the number of nodes on that. We have like the compatibility for all of them. Okay. At least I can say that. But I think that, I mean, at least my experience shows that it might be some other nodes which, for example, the default deny policy that we have and or the partial policy that we might actually propose to the node might be insufficient and kills the functionality of the node.
Got it. Okay. Okay.
But I should say that, yeah, I should say that it totally depends on the security policy that we define for each node.
I guess I don't even care about the security policy, right? Like when you run something in a clean VM, right? Like the fact, like a proxy is not enough, right? Like you have to like deal with species, you have to deal with instance, you have to deal with all the quirkiness. That this is not a real object, that this is a proxy object, and like that craps out sometimes when you call it to like deepen node, right? So like I think like my question is really like, it's possible for these class of applications that you won't hate those as much as you would in different classes of applications, right? And like it's totally reasonable to not have like a full like setting this as hardened like its own thing. I'm more curious like from like what you've done, but it sounds like there's like a mixed bag, and that sounds totally reasonable.
Yeah, at least that's my impression.
Cool. Okay, so I have questions about policies. So like you have your like what is it, your water leak example, and this is like a thing that I wanted to use like node for. But the thing that I'm paranoid about is I have like this global variable, right? And the global variable is like, are you allowed to like basically like water my thing or not, right? But like in a real thing, it might be a little bit more complicated, where you might have a sensor that also says like, hey, like the ground is like super dry, and that might in turn kick off some other part of your application that then toggles that thing. So I'm curious like how these things that might be interrelated like surface either at the policy level or somehow that I can like think about it without like necessarily digging deep in the code.
All right, so if I got your question correctly, so in this case, I think that the sensor node would be like a separate node from the water utility node, for example. So we actually, the default policy in Node-RED in our setup would be no access to none of the global or flow shared context. So it means that it's only the sensor node which is permitted to send data or like retrieve data to the global variable.
Got it. Okay.
So it should, yeah. I mean, in other nodes, there is no security policy for read or write to the, for example, tank level as the variable of the shared variable in the global context. But the sensor node is the only node that can write and read perhaps this variable.
Got it. Okay. Okay. I guess semi-related to this, but your like send mail example. I'm curious. So sometimes you're going to have an API that's like send mail, which is like very high level, or even like nodes at like HTTP. But sometimes you also need like a lower level package like net. So, and right, like if I like want to say like you can only send mail to like, Mohammed at example.com. Do you also instrument like the net package to like disallow SMTP, or what's your thinking there when you have like potentially kind of either intertwined or cross abstraction type policies? Right. And I don't know if there's a good answer. I'm just curious like what your thoughts are, to be honest.
Yeah, for example, I mean, that's actually one of the case studies that we have in the paper, and I can also show you the precise policy files for this case. But the whole idea is that actually the policies that will be generated would be for every built-in modules that it might require. So the higher level modules or the source level module doesn't matter. But for example, like net or I don't know, SMTP or other ones, you have like the hierarchy of module requires, and you can actually specify at this level I need this policy, for example. for example, in the email node, if I recall correctly, it was like the stream, I guess, that I put the policy on that.
Wait, so I guess I'm not following this. Like if I have like a policy for the mail like module, whatever that may be, you're saying that you're going to take that policy and somehow translate it into a lower level like policy that also applies to net?
No, maybe.
Okay.
Yeah, maybe I should correct myself. So the policy generation mechanism actually throughout an execution of the email node, it captures all the built-in modules that it might need with the APIs and everything. So based on that, the developer of the node, for example, can actually investigate the whole policy files and see which API is needed to be modified, for example. So in this case that you have like the net built-in module, so you should go to the policy for net, and in the APIs, for example, you should modify some of the value of some of the call policies as an example. But this net policy would be tied to the email node, not other nodes.
Yeah, I guess I'm talking like so I have a module, right?
Mm-hmm.
It's like it uses the mail interface because like it sucks talking to SMTP directly, right? But it also like uses the net module because, well, I want to talk sockets to some other like thing for whatever reason. Like this might not even be real, right? So I guess like my question is like, okay, like I need both for two separate things. So how do you make sure that like my net, I don't use it to actually send mail?
You need both for sending email, I got it correctly? Or?
Well, so the net is like a more general interface, right? I could just open a raw socket and then just like write SMTP or whatever, right? So
yes,
in some sense, like how do you prevent me from using the net library to send mail that's not according to the mail policy? Or you the answer could also just be like, you don't, because like that seems hard.
No, maybe I'm still not following you, or I know, but I can also show you, for example, the let me show you as an example of the email node. Maybe we can discuss it here. I can also share my screen perhaps. So here is the email scenario. So here is the policy. So you can see all like DNS, I don't know, OS, TLS, util, and everything, string here, net, as you said, right?
Yep.
So, and for example, I think that in this case, it was like stream and like transform and one of, I think, yeah, I don't know, one of the stuff here, maybe, I don't know, here, yeah, for example, here, this is where actually I put the policy, the values of the policy here. So at this level, we can actually prevent the emails to go to somewhere else. So, but you could also actually go to net and define another policy for this particular thing.
Yes, right. I agree with that. Okay. Right. I don't think it matters too much. Okay. I have a non-security question. So you're adding proxies all over the place, and these things are wrapping real objects. How are you garbage collecting things? Yeah.
So actually, we have also a discussion in the paper about that. So we have like the two proxy caches. So and if at the both worlds, I mean host and sandtrap, both of them are removed, then since the proxy caches that we have are weak maps, so there is nothing need to be worried about, because now the garbage collector can basically connect the free objects.
And you don't have to, yeah, and I guess the cycles are fine because it's always a weak ref across.
Yes, yeah.
Okay. Okay, sweet. Let's see. Okay, you were talking quite a bit about malicious stuff. And I guess I'm curious, so I assume that like Node-RED and all these other things, like that's not their attacker model. I'm curious, why are you taking this attacker model? And like, is there some motivation for like, these things are actually malicious instead of like, these things are applications that I use, but they're likely buggy. So I'm curious, like, have you seen malicious applications and like, what does this ecosystem look like?
So it's a very good question. Actually, I mean, for now, I don't recall any particular malicious nodes, but in general, for example, the malicious node email can be easily put on the Node-RED catalog or Node-RED app store, because like any other npm packages that you put on npm, you can do that for Node-RED nodes as well, and it'll fetch and publish on the Node-RED catalog. So basically, the idea is that there are some official nodes in Node-RED, which the name starts with Node-RED node, and there are other like third-party packages which start with Node-RED contrib, for example. And as an example, there are some unofficial nodes for example, Google services. So in that sense, you can say that there are some, for example, malicious nodes there. But I don't recall, at the moment, I don't recall any specific example that I can point at. But as long as anyone can actually develop and publish the apps, so it might be there, yeah.
Yeah.
Or I can do it.
I guess like what my concern is like, okay, so I think it's a reasonable way to think about things because it makes it easier. But if this is for real, like the attacker model, then you now have to worry about bugs in like Node itself, right? So you'd have to like worry about binding bugs, and then I guess like once you go to this model, how do you deal with the fact that like one module might be malicious? Like, are you always like sanitizing things that are coming across? And if so, how are you doing that?
So who are we, as you said, who are the sanitizer?
So if I'm in a world where like now like these modules aren't like malicious, right?
Mm-hmm.
Then I can't just take an application and just say put a sandbox around the boundary, right? I need to like actually check like, hey, this thing gave me a value. Could it be a total lie?
Mm-hmm.
And like, am I performing any kind of other control flow decisions based on that, right? So if you take like your water pump, right, like you may need to actually like sanitize, like kind of in some way like validate that the tank level is reasonable if that thing is malicious.
Mm-hmm. Mm-hmm. So actually it depends on the node specification. As long as you say that it's like, this is what I need, so I think that it's okay. And actually the end user can see the specification of a node, and in our system, it can actually scrutinize the policy of each node to see that which are the API calls that it needs. So I think that he would decide that this is like a malicious node or not. So for example, there is a Node-RED node called exec or something like that, that you can have like the full access to the shell script. So this is malicious or not, it depends on your purpose.
Okay.
So we can, we can say that, it's malicious. Like conservatively, we can say that it's like a malicious node, but yeah.
Okay. Now these policies. So for the Node-RED, they were huge. But it might not be huge, I guess, relative to like the actual application code. So can you give me some sense for that? Like it seems like for IFT and Zapier, the policy code was maybe like 150 to 200 lines of code or something like that. Like what's the ratio of that to like the application that you would write?
I think that I've experimented the impact of like having different built-in modules in Zapier, and we have one of the records in the table in the appendix, I guess, that all built-in module, and it shows that the ratio of having like built-in modules for Zapier code. But for the ratio of Node-RED nodes, I don't know exactly, but it depends on how many built-in nodes and objects it needs to communicate with the host.
I guess I'm going for more like a ballpark thing. Like you've written a bunch of these things, right? So like if you wrote 150 lines of policy, like for that particular like example, like was it 150 lines of code or was it like 1,000 or 5,000? Like just like ballpark.
Actually, I can't say something which I'm not sure about. So I think that I can check the Zapier cases because that was what I've measured. Because in Node-RED, for example, one built-in module might be used in many cases, so it adds the policy line of code drastically. So it totally up to the purpose of the node, but it's not like 1,000-ish thing, but it could be. I mean, if like your Node-RED node is too complex and does everything, so yeah, it depends on the Node-RED complexity. But for example, if you check out
so we can reframe my question to like maybe it's like a slightly different way of looking at it is and maybe this is an easier question to answer, is like, is the policy ever like more complicated than the code itself?
That's a very good question.
And like you don't have to bind it for all policies and all, just like
yeah, I'd rather say no because at least my experience says so.
Okay, yeah, that's what I'm going for. Okay, cool. All right, so access control versus IFC. It wasn't super clear to me why you actually want to do access control, at least for a bunch of applications, and seemed like information flow would do, and it might be a higher level, more declarative way of thinking about some of these applications. Am I totally off base, or I guess there's a pragmatic reason to do like access control, and you could presumably even build an IFC system on top of this for some of these TAP applications. But I'm curious, like why not like frame the mail policy as an information flow policy, and then you kind of have to care less about like individual objects and modules and all these other things.
So you mean having information flow control within a Node-RED node, for example?
Sure.
So yeah, the story was like this. I mean, we started with thinking about like IFC for Node-RED at the very beginning, like almost 2 years ago. But so the question that I had at that point was, so what's the point of having IFC as long as this is the APIs that exfiltrate data to outside? So we can also actually have like information flow trackers per node, which shows that, yeah, this is like the sensitive information that goes outside. But again, this is like the last API call, which exfiltrates data. So you can actually put the guard over the last API call rather than, checking the whole flow within a node. But you could also do that. I mean, it's also possible to have like information flow control within a node. And at the data level, for example, the Compose framework, one of the related work, they say that they did it with a JS Flow for Node-RED nodes. But again, our focus was more about actually breaking out the nodes rather than the type of information that might flow to outside. But for example, we could also define like information flow policies inside a node as well, yeah, if you would like.
Well, you can also do it at the boundary, right?
Sorry?
You can also do the information flow at the boundary instead of like necessarily caring what happens within the node.
Yes, but actually I'm not quite sure what would, in that case, what would be added to the value of like what we have at the moment, like access control of the boundaries. You know what I mean? I mean, so for example, information flow control inside a node. Yeah, I'm not sure that what it will add to the.
Well, okay, so here's I guess a concrete thing, right? So like for the like, and this is maybe like the made up like watering example where you have some sensor that says like, hey, is the ground too dry, and if it is, then we should be watering it, right? So right now, as far as I can tell, you'd have to have essentially two kinds of, you'd have to like manually say who's allowed to modify the water level or the do water the ground, right? And then like if you add this, if you have this sensor that says there is like an implicit kind of flow between this is dry and we should water things now, right? So now I have to like think about like, okay, like is this, I have to have presumably some kind of access control policy on this sensor itself, because like if I don't, then I can just mess with the is dry, you know, global variable, and that I can use that to then water things indirectly, right?
Yeah, you're right. But so now actually the problem in this case would be that the sensor node, which actually writes to something which is globally shared. So any other nodes could actually read the global shared. So what would be a suitable IFC policy in this sense? Just from like another node to another node? I mean, two different specific nodes, or in general? Because
well, you could imagine just having a policy saying that you're allowed to, this sensor can flow to this actuator, right? But nothing else.
Yeah, so if it's like directly linked via explicit wiring, so basically it says so. I mean, this actually specifies the information flow from one node to another. You know,
Okay.
and that's what actually user can see. So otherwise, if it's via like the shared context, like as we're talking about, like the global variable, so it can be shared within all the nodes in all flows. So it might be like,
but it doesn't have to be, right?
But it is how Node-RED works. So
I mean, kind of. You're modifying how it works anyway, right?
no, we're not modifying the. We're just actually predicting each of the nodes, but not modifying the execution of any Node-RED flow. The execution of a Node-RED flow remains the same, remains as before, right?
I guess I don't. Well, okay. This is a red herring. I don't think it matters too much. I think my question was answered. Okay. So from this stuff, the last bit on the low level stuff that I have questions about is the non-transitive stuff. So the result is cool. I guess I'm curious, like how it ties in with the rest of the things that you're thinking about, and where do we actually care about? Like, what is a real policy that you'd care about in the context of that of the frameworks that you're looking at?
Actually, the paper, the CSF paper by Lu and Zhang has some motivation examples, and one of them are, for example, the scenario of confused deputy, that you have like a component that might be misused to retrieve some data from a sensitive like data set or something like that. So the main information here would be the programs contains of different modules or components. And now we're actually, for example, we have like downloaded something from somewhere when we're gonna attach it to our program. So we don't want to trust the policy, for example, the security label that the developer of the module says that, yeah, it's like safe, just accept it. We are gonna label it as like untrusted or insecure in some sense. And then instead of labeling each of the variables inside the module, we just label the module as is. So that would be like a coarse-grained version of labeling. So for example, another possible scenario would be like in social media, for example, that you say that, yeah, this is my photo and my friends can see, but not friends of friends. And this can be.
Sure. Yeah, I mean, yeah. Like my concern is like when we go to this world, you give up on like the nice bit that we get from ISE, which is that you get a way to think about systems in a compositional way, right?
Mm-hmm.
And there are definitely policies that can have like negation in them, but it seems to me that like if what you're saying is that like we can build systems out of these like non-transitive things, I think like we're like bad enough at building it out of transitive things. So I'm curious, like is there actually like in like the TAP examples that you were looking at, like things where you would care about this, or is it not? Because even when you convert it to like your like IFC world where you're like, okay, like we have a different lattice and we can just encode this, right? That still kind of like somehow breaks composition, right? Because suddenly you need to like rewrite what would be an off-the-shelf module.
So the idea would be that if you have like one of the off-the-shelf modules that you want to add to your program, so you should actually explicitly say which other modules or components can flow through this module or get the information out of it. So in that sense, the non-transitive policies might be helpful because now you should, I mean, you don't need to be worried about the how actually you don't need to be worried about the like implicit transitive flows which are not desired.
I guess I don't buy it, right? Like if I bring in like libjpeg, do I really care about like what zlib is doing underneath the hood, or like the fact that like and worry about like, you know, them replacing zlib with something else? Like it seems like if we're trying to build bigger systems, we want to be able to like draw a boundary, right? That is one we care about, not necessarily the internal details of the implementation of this particular thing. And it seems like once you break this transitivity, you have to think about this, right? Or maybe you don't, but I'd be curious, like why you
wouldn't. So I guess that in your case, so how right? Okay, if the component that you add needs some other components in your program, what will happen in this scenario?
So in the IFC world, right, like I can pull in a library that itself uses a library, and I don't need to think about that in a library, right? But in a, yeah, go ahead.
Yeah, but what if the library needs some other libraries which are not trusted?
I think that's the whole assumption that we make, right? Is that we can just take these things and compose them.
Okay, so maybe I'd say that in this case you actually label the whole series of components which are dependent to each other as one security label, right?
But not right. So I guess to me, non-transitivity breaks abstraction, right? So like my real question is like, when is it worth it?
Breaks up abstraction Mhm. Right, but you still can say that I mean, as I think that you still can say that all the the modular components that are connected to each other, and you think that uh, they are they're necessary for this functionality are in the same security level. So it, I mean, if you have like a bigger module that includes some other inner modules, so you could label the bigger one as something. This wouldn't break the abstraction, I guess.
Okay, yeah. All right. Down with my low-level questions. I have two high-level questions. So first, what is your thesis?
Okay. So, all right. So the idea of our thesis is to provide, like the first two paper was about securing trigger action platforms, which are like the connection of different apps and different modules that are running simultaneously. And for the third paper, the non-transitive policy, it also the main problem talks about like having modular programs, and the thesis in general would be yeah, the connection of these two in the whole way. But the first two papers are really connected to each other.
No,
But the third one,
I don't mean like mechanically how you're gonna write your thesis. I mean like like 3 sentences. Like what is your thesis of the world? Of how we should build systems, right? Like,
all right, so that's a tough one. Okay, I think that yes, at least we have for the we have like two we have like two solutions for both access control and information flow control policies, which should be actually reflected when you add like employ another module out of nowhere, like third-party code. So you should be careful of these two policies, and we're here to help you in some senses. So the policy, the first application would be like the trigger action platforms that we investigated, but for example, Sandtrap could be used for any other third-party JavaScript code. And for the non-transitive policies, it can be also used for, like as we discussed, any policies that we don't want to be transitive. So it depends on you that if your requirement is like in this way, then you can pick non-transitive policies or any other ones like DLM or DC, or you want to have like this transitivity relation in your policy, so then just pick what we already had in the literature. I hope that I answered this one.
yeah. All right. So last question, and related to this, is like, what's next?
What's next? So for each paper, there are some future work. So for example, for the non-transitive policy, it can be actually combined with some notion of like declassification or dynamic policies. So we had some rough ideas on them, but we can still work on that thing to make it like more practical, because I think that the integration of declassification and non-transitive policies can be interesting. And for the trigger action platform scenario or Sandtrap, there are some future work here. For example, one of them could be like how like giving like a formal framework for the full-featured Java, full-blown JavaScript language here, or like trying this in practice with different other trigger action platforms which are related to JavaScript, or at least, for example, see that how this threat model can be employed in other scenarios, not just trigger action platforms. And also, so for example, we focus on like confidentiality and integrity policies. So if somehow, at least we can actually investigate that how much of the like other policies, such as like availability policies, can be enforced in this way or in a similar way. Or like changing the attacker model. No.
Did you say blockchain?
No.
Oh, changing the attacker model. Okay.
No, changing the attacker model. Okay. Yeah, using blockchain for non-transitive policies inside trigger action platforms. Like other empirical studies on like different platforms could be also feasible. And what else?
That sounds like plenty of stuff.
Yeah.
Cool. Okay, awesome. I am done grilling you. This is really nice stuff. I should have started with that. I may have read your papers a while back and really liked it. That's I think why Andre came.
Yeah. Awesome. Thanks for your question, and I hope that I answered your question. Yeah.
Yeah, totally.
Okay. Thanks very much.
Thanks very much indeed.
Diane, for the great questions. Thanks for the discussion. And at the moment, we have room for questions from the audience. We have both physical audience, we have 8 people in the room, and people who are here are as welcome to ask any questions as people who are participating remotely. Feel free to raise your hand or write the question in chat or just tell us the question. So yeah, floor is open for questions at this point. Check. Yes. Yeah. Okay, so there's a question in the chat, right?
Oh, yeah.
Okay, so yeah, there's a question in the chat. Yeah, I mean, you see it, right?
Yes.
So go for it.
Yeah. So William says that on the mail versus net issue, wouldn't the mail object have access to credentials that net doesn't? Yeah, it might be the case. So yeah, I think so.
So this is kind of following up on the discussion, right? Of there are several ways of sending email. Mm-hmm. One of them from high-level interface, but there might be low-level ways of sneaking in.
Yeah.
So yeah, kind of it's possible to have a policy that allows one thing but not the other.
But not the other.
Okay, so basically this kind of consistency policies questions. What's your take on that?
Right. Yeah. So. Yeah, I mean, if it's like the credential that passes from the mail node to net, so it can be captured on both. But yeah, I think that the mail object have access also to some other credential that still net doesn't. I guess so.
Okay. All right. Other questions? No question.
I have a question about sandboxing. So I think it maybe relates a bit to the questions that Dayan started off with. So I haven't looked at sandboxing of JavaScript since sort of way back when we were looking at web browser sandboxing. And it seemed to be very difficult. in particular required a lot of code and a lot of very careful coding in order to fill up all the holes. And even then, you were never quite sure that you hadn't missed something. Would you say that the platforms in which JavaScript is running, the examples that you looked at, are easier than web browser sandboxing?
Actually, I'm not the best person to answer this question. Maybe Daniel can answer it better, but I think that, for example, it depends on the architecture of each platform. So, for example, like in IFT, which there are more restrictions and like the interactions between host and sandboxing board is like less than what we have on the browser or something else, I would say yes. But for example, what we have on Node-RED I mean, I'm just comparing the complexity of the sandbox that, for example, Node-RED might need with the full accessibility might be comparable with like web browsers.
Right. Thanks very much.
Any further questions? Sander?
Yeah, I have a slightly technical question about the non-transitive non-interference. So you have this transpiler, and then you're using a traditional system to sort of check the core, as I understand it. And I'm wondering, what about the init and the preamble and the sort of last bit, the init and read out the temporary variables. Is there any sort of flow checking there as well, or would that be?
Yeah.
It seems that if something could go wrong, we would have to be a mismatch there, right?
Yeah, thanks for your question. Actually, we use the flow-sensitive type system on the transformed program. So it means that the whole thing, like the bunch of source variables, the program itself, and the final values, the final assignments, all of them are checked through the flow-sensitive type system. So the flows from source variables will be carried on in the program, and at the end will be captured in the last assignments.
It seems kind of magical, since you're not changing the semantics, but somehow, I mean, what exactly are you changing then? If end to end, somehow you're still, isn't it still the same analysis?
Same analysis.
I mean, where does the non-transitivity actually show up then? In the...
Okay, all right. So I should say that, for example, non-transitive policies in general, for example, when you say A can flow to B, it means that the source of information from A can flow to sync to information sinks of B. You know, so in this sense, these two source and sink, like I would say, variables of each class should be separated. Otherwise, you would need the non-standard type system that at each of the like assignments checks whether the the collected labels through the program is like a subset of the CANFlow to set.
I guess what I'm missing is how exactly then the assignment to the temporary variables is helping in that particular case. But maybe we should take it offline. And maybe it is quite a technical question. So.
Yeah, but just assume that the temporary variable as internal, and we have like we labeled them as the top element of the lattice. So in this sense, the flow sensitive analysis can help us to update the security levels through the execution.
Right. That was something like that I was imagining going on, but I mean, there's still a question.
Yeah, sure.
But I think we can take that on.
First.
Sorry.
Sounds good. So maybe we finish with Mati's question in the chat about moving away from JavaScript to other adventures.
Yeah, thanks. So the question says, would you recommend moving away from JavaScript as the language to write these apps in, or are you confident that tools will have good enough eventually? Okay.
Can you mask that?
Sorry?
Can you mask that? Sorry, I'm joking.
Yeah. Okay. All right. Yeah, one idea could be like designing a new language that support everything that JavaScript brings to us but in a secure way, like secure JS, something like that, which, for example, SES is one of the attempts to do that. And of course, not completely successful. But yeah, I think that at the same time, though, we need the features of JavaScript, and we should develop some better and better tools for security. And I think that, yeah, maybe in an ideal world, we can say that the JavaScript as a language and our, like, the whole effort of the security committees are trying to do that from the PL part of me. Yeah. First, it's something like that. Yeah, but I think that there are some attempts, there are some tries to provide security at the level of the language, but at least they're not completely compatible with the apps written in the platforms that we tried. Otherwise, we would be much happy to not develop another JavaScript monitor.
Okay, so on that note, so I'd like to first thank Dejan for waking up before the birds. That's very much appreciated, and of course for the excellent questions. That for Mohammed is going to be excellent feedback for the rest of the PhD.
Indeed.
So thanks very much, Dejan. Thanks very much to the audience for attending, and thanks very much to Mohammed for taking care of the questions. Now, the verdict will be done by our examiner, David Sands, if this will actually be sufficient for Mohammed to get his degree.
So is that my cue?
Yeah.
Yeah. Okay. So thank you, Mohammed, for the presentation. Thank you, Dejan, again for helping us with this stage in the PhD program. So I'm happy to announce that you have successfully conducted and satisfactorily conducted your Licentiate Seminar and Licentiate thesis. So now you have the Licentiate degree waiting for you on a hot piece of paper somewhere. So congratulations on that, and we look forward to the second half of your PhD with bated breath.
Thank you, sir.
Congratulations.
Yeah, thank you, everyone. I should, of course, thank Andre, Dave, and all my collaborators in both papers, Daniel, Musard, and Aslan. And thank you, of course, Ian, for the questions. I've recorded the whole session, and I'll actually check whether I found any better answers for your question. I'll keep in touch.
Okay, great. Thanks, everybody. That's the end of the meeting.
Yeah, thank you.